How does Python super work with multiple inheritance? How does super work with multiple inheritance? For example, given. Which parent method of third does supered underscore underscore init underscore underscore refer to? Can I choose which runs? I know it has something to do with method resolution order, MRO.
This is known as the diamond problem. The page has an entry on Python, but in short, Python will call the superclass's methods from left to right.
This is detailed with a reasonable amount of detail by Guido himself in his blog post method resolution order, including 2 earlier attempts. In your example, third, we'll call first at underscore underscore init underscore underscore. Python looks for each attribute in the class's parents as they are listed left to right. In this case, we are looking for underscore underscore init underscore underscore. So if you define, Python will start by looking at first, and if first doesn't have the attribute, then it will look at second. This situation becomes more complex when inheritance starts crossing paths. For example, if first inherited from second. Read the link above for more details, but in a nutshell, Python will try to maintain the order in which each class appears on the inheritance list, starting with the child class itself. So, for instance, if you had the MRO would be fourth, second, third, first dot. By the way, if Python cannot find a coherent method resolution order, it'll raise an exception, instead of falling back to behavior which might surprise the user. Example of an ambiguous MRO. Should third's MRO be first, second, or second, first? There's no obvious expectation, and Python will raise an error. Why do the examples above lack super calls? The point of the examples is to show how the MRO is constructed. They are not intended to print first backslash and second backslash third, or whatever. You can, and should, of course, play around with the example add super calls, see what happens, and gain a deeper understanding of Python's inheritance model. But my goal here is to keep it simple and show how the MRO is built. And it is built as I explained.
Your code, and the other answers, are all buggy. They are missing the super calls in the first 2 classes that are required for cooperative subclassing to work. Better is. Output. The super call finds the next method in the MRO at each step, which is why first and second have to have it too, otherwise execution stops at the end of second dot underscore underscore init underscore underscore. Without the super calls in first and second, the output is missing second.
I wanted to elaborate the answer by lifeless a bit because when I started reading about how to use super in a multiple inheritance hierarchy in Python, I did get it immediately. What you need to understand is that super, my class, self, dot underscore underscore init underscore underscore, provides the next underscore underscore init underscore underscore method according to the used method resolution ordering, MRO, algorithm in the context of the complete inheritance hierarchy. This last part is crucial to understand. Let's consider the example again. According to this article about method resolution order by Guido van Rossum, the order to resolve underscore underscore init underscore underscore is calculated before Python 2.3 using a depth first left to right traversal. After removing all duplicates, except for the last one, we get. So, let's follow what happens when we instantiate an instance of the third class, e.g. x equals third. According to MRO, third dot underscore underscore init underscore underscore executes. Prints, third, column entering. Then, super, third, self, dot underscore underscore init underscore underscore, executes and MRO returns, first dot underscore underscore init underscore underscore, which is called first dot underscore underscore init underscore underscore, executes. Prints, first, column entering. Then, super, first, self, dot underscore underscore init underscore underscore, executes and MRO returns, second dot underscore underscore init underscore underscore, which is called second dot underscore underscore init underscore underscore, executes. Prints, second, column entering. Then, super, second, self, dot underscore underscore init underscore underscore, executes and MRO returns, object dot underscore underscore init underscore underscore, which is called object dot underscore underscore init underscore underscore, executes. No print statements in the code there, execution goes back to second dot underscore underscore init underscore underscore, which then prints, second, column exiting, execution goes back to first dot underscore underscore init underscore underscore, which then prints, first, column exiting, execution goes back to third dot underscore underscore init underscore underscore, which then prints, third, column exiting. This details out why instantiating third results into the MRO algorithm has been improved from Python 2.3 onwards to work well in complex cases, but I guess that using the depth first left to right traversal plus removing duplicates expect for the last still works in most cases. Please comment if this is not the case. Be sure to read the blog post by Guido.
If you want to support the channel, please consider liking and subscribing.